Okay, we're in 7, the triangles, and certainly we're going to talk through it. Again, my emphasis over here is that we're going to go through lecture material. We're going to do examples. And after doing the lecture material and the examples, you should study that material, do the supplemental problems that are contained in these notes, and then do the web assign, not the other way around. All right. You want to learn the material. All right. So what we've done is certainly we're prepared notes for you, as you probably are well aware of at this point, and we're going to go through this. All right. We'll go through some basic introductory information on triangles. We'll talk about, really simple right triangles as they relate to what we've done in the past. And that is we've done, that circle problem with the understanding we have these functions defined with respect to that circle. And triangles are going to be part of that circle problem. And we've done that. We've done that. Law of signs, we'll cover it. The way I'm going to do that, again, it's going to be basically, do you understand what was presented in the past? And if you do, there's a future here. You can actually derive these formulas pretty simply. They're really simple. We're going to do the law of cosines. We'll derive that. And then what we're going to do is we're going to go to the examples. And when I go to the examples, I want to point out that the problem for a lot of students is that every triangle is the same triangle. And that's not true. Not all triangles look the same. So you'd have to be able to read, understand what you've read, visualize what you've read, and then answer their question. Now, solving a triangle means coming up with 6 pieces, all right? 3 sides, 3 angles. However, some of these word problems, they don't want to know all the pieces. They want to know one piece of it, and make sure you can do that, all right? So what I'm going to do now is I'm going to switch to the whiteboard. And as I switch to the whiteboard, my emphasis is going to be on lecture. Once the lecture is covered, then my emphasis is going to be on how does that lecture apply to the examples that follow? And it better apply, all right? Why else do it? So I'm going to do another share with you. And I'm going to go to my whiteboard. I'm going to plug it in. Give me 1 second. Give me a second. I'm having a little issue here. I'll plug it in. All right, you got my whiteboard. All right, so let's talk through it, and I'm going to talk beginning to end. So I'm looking at this thing over here. It says introductory information you're probably aware of, but maybe not. All right, so it's best not to assume too much. So I'm going to say it's somewhat traditional when dealing with triangles that we use uppercase letters A, B, and C to indicate the angles. All right, really important. And I'll draw a picture of that in a second. And the sides opposite of that angles are the lengths, and they're in lowercase letters. All right, so this is tradition. All right, now could we break tradition? Of course we could. So I'm going to go over here. I'm going to draw like this generic triangle. And this is the one that most students draw, believe it or not. All right, it's a triangle. Now, someone's going to say, do all triangles look like that? Of course not. This is just an abstraction of a triangle. So I'm going to say this is angle A here. This is angle B here. And this is angle C over here. And they're uppercase letters. Now, what do we say? It's convention that we have these uppercase letters to represent the angles. Now, the side opposite the angle A, this is side opposite angle A, it's opposite that. We're going to label it side A with the lowercase letter. The side opposite angle B, we're going to call that B, and we're going to use a lowercase letter to do that. All right, the side opposite angle C, we're going to call side C. Now, I hope you realize that A, B, and C, those lowercase letters, are lengths of the side of that particular triangle. What are the angles A, B, and C? Well, they're the angles of the triangle. And we know this. We know that angle A plus angle B plus angle C is 180 degrees. The sum of the interior angles is 180 degrees. All right, so I'm going to say, we did the preliminary stuff. And now we're going to talk about right triangles. And when I talk about right triangles, I got to tell you something. You certainly, I see the definition down over there. Some of these are new definitions. What I want to do is, I just want to draw a picture of what we've done in the past And what we've done in the past, we've done this circle problem, and I'm hoping you remembered that. All right, so I'll put the circle down over here. And I'm pretty sure I called this thing the abscissa. You can use X if you like. And this is the ordinate Y, I'm sorry, B. I'm sorry, I said Y, but the ordinate B. And then we have a point on the circle. I'll put the point over here. The point would be what? A, comma, B. And this is a circle, and we know the circle to have a radius R. I'm just going to call the radius R C. Now, so why use those letters? That's something to do with a triangle. So what do we know? We know there's an angle here in standard position. And what's that going to be? Well, I know about these angles. And if I look at that angle there, and I'm going to say theta is in the first quadrant, that means it's between 0 degrees and 90 degrees, right? That's an acute angle now, right? Well, I know some relationships now. I'll tell you what the relationships I do know. I know that a squared is a circle problem plus b squared is equal to c squared. That's an important relationship, by the way. That relationship's given to you right over here. That's a Pythagorean relationship. Now, what else do I know? I'll write this down for you, all right? And someone says, do I know these things? You do. You should know these things. You should know the sine of theta is defined a certain way. And let's talk how it's defined. How's it defined? Well, it's defined as the ordinate, which is, you know what? I noticed that I have a problem here. And I want to tell you what the problem is. My diagram is not labeled according to this thing over here. I'm going to relabel the diagram, and I apologize for that. Over here, erase that. It's an interesting thing why it's that. And I'm going to say it's not a mistake. I was reading my notes. This is called B, and this is A. It's incidental, by the way. It really is. And what I mean by incidental, it doesn't matter what you call them. It's an idea about this ordinate abscissa. Let me erase this over here. Okay. And this is going to be B, which is the abscissa, and A is the ordinate. All right. I still have the relationship A squared plus B squared equals C squared. That hasn't changed. Right. So how's the sine defined? It's defined as the ordinate. Well, the ordinate in this case is A over the radius. In this case, it's C. All right. How's the cosine of theta defined? Well, the cosine of theta is defined as the abscissa. In this case, it would be B over C. All right. And how's the tangent of theta defined? Well, that's defined as the ordinate, which is A, over the abscissa. In this case, it's B. Again, you can change those letters to anything you want. It doesn't have to be A, B, and C. You call it alpha, beta, and gamma if you want. Whatever you want to do, all right? But you need to know the definitions. So I'm going to point out the definitions are over here. I'll write this down for you. In green. According to my picture, I got this. Well, we have this too. I'm going to say that. According to my picture, we have this. According to my picture, we have this over here. All right, now what I'm going to do is I'm going to put something in. And somebody said, why would you put this in? Because there's going to be names now. And I'll just put what we call a triangle in. And someone says, what triangle is that? That's what's known as a right triangle, that this is a right angle over here. All right. I want to claim what this is over here, though. This would be this side, according to this picture over here anyway, A. And what's this thing over here? This is going to be side B. Okay. Now I'm going to say I noticed another thing about this over here, that they didn't call it theta, they called it A. Get my eraser out. Erase this business over here. I'll write that down for you. And I'm going to erase that theta over there. A little tough for me. It's a little small theta, isn't it? And I'm going to say it's angle A now. Okay. So what's side A? It's opposite angle A. Let me tell you what that is. okay? What's C? It's actually the hypotenuse of that right triangle. All right, let's go to the cosine of A. Well, again, look at my picture. And what do I see? Well, what is side B related to that angle A? It's what we say is adjacent or next to that angle. So a lot of times when you studied, if you did study trigonometry at a more basic level, they would have defined the trigonometric functions with respect to a right triangle. There's nothing wrong with that, but it goes back to what we did in the beginning of the semester. And what's C? C is the hypotenuse of my right triangle. Now, if we did tangent, what do you get? Well, what's A? It's a side opposite angle A. What's B? It's a side adjacent. So a lot of times you often hear the sine of the angle A for a right triangle is the side opposite to A over the hypotenuse, so forth and so on. Now, I want to, I have other mistakes over here. Oh, not mistakes. I'm not saying mistakes, right? Let's draw a picture now, all right? I shouldn't say there's no mistake there. We just did these. All right, I'm gonna do another little picture over here, and I'm gonna just draw a picture without the circle. Right triangle. I'm gonna call this side C. I'm gonna call this angle B. I'm gonna call this angle A. This would be side A. This would be side B. All right, I'm gonna write down 3 more, right? And it shouldn't be much of an issue over here. Let's write this down. The sine of B, well, that would be the side opposite of B, which would be B over the hypotenuse. See what I'm doing? Cosine of B would be the side adjacent to B, which is A over C, and the tangent of B would be the side opposite B, which is B, over the side adjacent to B, which is A. All right? And again, it really goes back to my triangle. Here's the deal, though. What's this angle here? It's got to be C. So C is typically taken to be 90 degrees for a right triangle. All right? It doesn't have to be, though. You can switch these letters around. Just like before, I started with letters and I realized my definitions were written differently. I had to adjust my letters. All right? So let's tell you where these guys are. A little box on it. It's these guys over here. Oops, sorry about that. Sine of B is B over C. Cosine of B is A over C. This is only for right triangles, by the way. And the tan of B is B over A. Now what I want to do is I want to go law of sines and push this up. I'm going to blow this up a little bit, and I'm going to talk through it. All right. So someone says, what's the law of sines? It can be written in 2 different ways. And I'll outline them for you. It could be written, whoops, sorry about that. Could be written this way. Could be written this way. Okay, so what does it say? It says over here that we're going to derive that formula, and the formula is really easy to derive, but I want to point out to you that although easy to derive, it can be highly misleading unless you have an image of what we're talking about, and I'll tell you why that is later. I'm going to draw a picture. Now, it could be a right triangle. I'm not saying it's not. I just want to make something that doesn't really look like any triangle in particular. This is side B. This is side C. This is side A. What I want to do is I want to make a right triangle, though. I'll do this. And this is called the height or the altitude of the triangle. So I'm going to write some things down here. And what I want to write down is, sine of angle A. And again, I'm using different letters now, right? Well, what's that going to be? I'm looking at the right triangle. It would be the opposite side of A, which is 8, over the hypotenuse of that triangle, which is C. What I'm looking at. I'm looking at this right triangle here. All right, let's put another one down. The sine of C, well, I'm looking at this triangle now. Hey, you might have twisted your head around a little bit, but it's not so bad. What's going to be h over a. All right. Well, I'm going to just write these a little bit differently. This is c times sine of a equals h. And this is a times sine of c equals h. I hope you can agree on my picture. H's are equal. So what does that mean? C times sine of A should be identical to A times sine of C. All right, they do something spiffy here. They divide both by sides by AC. And what would happen over here? Well, I hope you realize there's a cancellation there. And there's a cancellation there. And let's write down what you get. What do you get? Sine A over A is sine C over C. Okay? Now someone says, could I continue to do that? And you can. You could actually turn the triangle around and get a relationship between A and B. Right? You could do that. All right? Let me go through that with you. I'll push this on the side over here. They're really kind of same triangle. Put this over here. Switch things around. You know what, if I switch that around? Yeah, maybe. Let's see, A, B, and C. I think you get the idea. You could just permute those things around. And let's do that, all right? Same deal. Right triangle. This is H. This is side B. This is side A. And this is over here, side C, the whole thing. Let's write this down. Sine of A is H over B, right? Sine of B is H over A. I think you get the feel for this. What are we doing? We're just in a loop of permitting things around. So I could say over here, if I put B over there, what am I getting? Sine A over A would be identical to sine B over B. You know, maybe I'll go through that with you. Maybe it's not obvious. Sine A times B equals H. And this would be A sine B is equal to H. If H equals H, I get B sine A equals A sine B. What would I do now? Divide both sides by AB. And what happens over there is the B cancels there, the A cancels there. And what are you left off with? Sine A over A would be the same thing as sine B over B. So we're getting a nice relationship. Again, the relationship I want to point out to you, we're getting this thing over here. Okay. I want to tell you why this is so bad, though. If you're blind and you don't see your triangle, you might be horribly upset that you get the wrong answer. So what I'm going to claim over here is the reason for that is the sine of theta is identical to the sine of 180 degrees minus theta. So for example, the sine of 45 degrees is the same as the sine of 135 degrees. Now, I gotta be honest with you, if your eyes are closed, 45 degrees and 135 degrees, you couldn't tell a difference. If your eyes are open, you would know there's a difference. This is why I'm going to emphasize you need to draw a picture. And this can get very confusing, very confusing. Let's go to the next page. We just did the law of sines. Yep, you need to know that. And as we do problems, we'll go through it. All right, next up, law of cosines. And let's put this one down over here. I'm going to draw my picture. I'm trying to develop a law of cosines. I'm going to put one vertice, maybe put a different color. One vertice there. I'll come over here, put a vertice there, and for sake of argument, I'm going to put a vertice over here. This is my triangle. I'm going to label it, and I'll put down this is angle A, this is angle B, and this is angle C. All right, I'm going to start labeling the points. Oh, let me do the sides first. This is side A, this is side C, and this is side B. I'm going to label points now. This is going to get tough, but let's do it. This point here is the origin, 0, 0. This point here, well, the length of that side is C, so it would have to be C comma 0. All right, I got those 2 points down. Now what I want to do is I want to do this point over here. This is where a lot of students struggle with it. But the deal about it is it's sort of like if you drew a circle in there going through that point, I'll just kind of do that for you. You get the idea, right? So I got a defining feature of this thing over here where the understanding is we're talking about, you know, this is circle here. I'm not doing a great job over there, but this is the angle A, right? So what was this thing? Again, if you just you got rid of the triangle, you would clearly see, I'll write this down for you, that the sine, I'll write this down for you, of A, what's that going to be? Well, let's go through it. All right, let's go through it. And someone says, it's going to be something, right? What is it going to be? It's going to be, there's a point over here. And I'm going to say this is the x-axis, and this is the y-axis. And what's the point over there? X, comma, y. So how's the sine defined? Well, it's defined as the ordinate, which is y, over the radius. Well, what's the radius of that circle? It's b. All right, that's not so bad. And what's the cosine of A defined as? The abscissa, which in this case is x, over the radius of that circle, which is b. So now I know what x is, and I'll put this over here. And what's that going to be? It's going to be b cosine of A. And what's y going to be equal to? B sine of A. All right, I got some interesting facts over here now. I'll tell you what the facts are going to be. I'm looking at a problem where there's a distance. And I'm going to talk about the distance A. And the distance, I'm going to use a distance formula. I want to point out, I'm using a distance formula. I'm seeing this point, and this the distance between those 2 points. Well, I'm going to use a distance formula. And the distance formula has to do with points. Let me write this down for you. Let's see what's going to be. Well, it's going to be, let's see, it's going to be B cosine of A minus C, this is this formula in Math 100, plus B sine of A minus 0 squared. All right, use distance formula. All right, so we took this point here, and this point here, and that distance there. Of course, I'm going to try to figure this one out now, and I'm going to square both sides. You get A squared, and you get B cosine A minus C squared plus, well, this is just B sine A squared. Let's do it. You get A squared. This would be B squared cosine squared A minus 2BC cosine of A. Wow, it's going to go on for a long time, isn't it? Plus C squared plus, I want to point out what we just did. We just did this part here. Now I'm going to do this part. And what would that give me? B squared sine squared A. I'm going to rearrange this thing. A squared. I'm going to take this term and this term, bring them together, but factor out B squared. So you get B squared, whoops, I'll go back to black ink, times cosine squared A plus sine squared A plus C squared, that's that guy right there, minus 2bc cosine of A. What do we have here? A squared, B squared. I hope you realize that cosine squared A plus sine squared A is 1, plus C squared minus 2bc cosine of A. All right, let's go back. I want to point out they've got that formula written down. Someone says, where's that formula? It's right over here. Well, just like we did for sines, you can permute the sides around, the angles around as much as you want. And you'd get these three formulas over here, and you should see how identical they are. Right? Those are permuting letters around, that's it. So if you know one, you know them all. All right? There's not three of them, there's one of them. All right? So I'm going to claim that we're pretty much done, but I want to warn you. The law of sines can be very dangerous. It can mislead and give you wrong answers. This is why you absolutely need to draw a picture. Let me repeat this. The sine, let's say we'll put an angle down like 13 degrees, is identical to the sine, and this law of sines, by the way. Let's see, 180 minus 13, that's going to be 167 degrees. Now, if your eyes are open, I think you'd probably know the difference between 13 degrees and 167 degrees. This is why your eyes need to be open when you're doing this. And we'll go through examples, by the way. The law of cosines, although difficult to do, doesn't lead to wrong answers. The law of sines can lead to wrong answers. This is why you need a picture. Right? Furthermore, there'll be some examples in the notes where things are ambiguous. They could be both. For example, the picture could lead to 13 degrees and it could lead to 167 degrees. It's ambiguous. And these will come up when we're doing word problems. All right. So I'm going to say we're done with this section. What do we basically do? Right triangle trigonometry, law of sines and law of cosines. Thank you.